All right, good morning, everyone. Thanks for joining in for the Quarkus session. So right now, the latest version of Quarkus, which is available, is 2.14.3. Now, we call Quarkus as supersonic subatomic Java. Why do we call that? I'll explain in further slides. So what is Quarkus? A Kubernetes native Java stack tailored for OpenJDK hotspot and GraalVM, crafted for the best of breed Java libraries and standard. Couple of fancy terms, I'll explain them, what each of them they mean. So coming to the agenda today, the agenda will be, we'll start with introduction of Quarkus, features of Quarkus, why do we need Quarkus? We will see the performance, how Quarkus behaves. Then we will have a basic application using Quarkus. We will also see some of the error messaging in Quarkus, how it is different from other Java frameworks. So that is planned for day one. For day two, we will go ahead and build a REST application involving database and other third-party tools. That's the plan for day two. And on day three, we will be covering detailed discussion between Spring and Quarkus. So which is better, which is not better, when to use Spring, when to use Quarkus. So all those stuff we will discuss on day three. Now, if you guys ask me to introduce Quarkus in one phrase, I would say it's a container first cloud native framework. A detailed description of Quarkus is it's a Kubernetes native Java framework tailored for GraalVM and hotspot. So what is Kubernetes? Kubernetes, also known as K8, is an open source system for automatic deployment, scaling, and management of containerized applications. So that's Kubernetes. Now, I also introduced a term called GraalVM. What is GraalVM? It's a tool for developer to write and execute Java code. What is hotspot? So hotspot, it was initially released as Java Hotspot Performance Engine. It's a virtual machine for desktop and server computers. Now, Kubernetes native Java framework tailored for GraalVM and hotspot, crafted from best of breed Java libraries. So Quarkus uses the best of Java libraries and standards. Now, the goal of Quarkus is to make Java a leading platform in Kubernetes and serverless environment. What is serverless environment? So serverless is a cloud native development model that allows developers to build and run applications without having to manage the servers. So most of the time when we run our application, you guys would have heard of the term called Apache Tomcat, etc. So what is Apache Tomcat? A server on which our application runs. But when we focus on serverless environments, so me as a developer doesn't have to go ahead and manage those servers. So that's a serverless environment. It is a cloud native development model that allows developers to build and run application without having to manage these servers. So in a serverless environment, Quarkus offers developer a unified reactive and imperative programming model to optimally address wider range of distributed application architectures. Now, I'll take a pause here and I'll wait for questions from you guys in case you guys have not understood any of these specific terms or you have heard these terms for the first time. I'll assume the silence is no, so feel free to speak up in case you are not understanding any of the terms here. Okay. In that case, I'll move to the next slide. Now, Quarkus helps us with both imperative and reactive programming approach. So what is imperative programming approach? Imperative programming is the code is executed based on the statements. They are written in an order that details every single step that the program has to do before the task can be completed. So this particular thing which you see here, this is an example of imperative programming where we have a method and then few of these statements are. The statements will be executed based on the steps in which they are written. That's imperative programming. What is reactive programming? So I'm not sure if how many of you have heard of the term called Kafka, but in Kafka, we use the approach of reactive programming where input comes in the form of streams. So a streaming set of data comes in and we go ahead and manipulate that streaming data using reactive programming. So in case of reactive programming, the framework registers a callback and then the framework is responsible for calling the callback correctly. So callback functions are involved in reactive programming. Now Quarkus supports both imperative and reactive programming. Let me move to the next slide. Yeah, these are pretty heavy slides where a lot of theory have been written, but I'll quickly summarize what they mean. So in the beginning, I defined Quarkus as a container, cloud native container first application framework. Now, since the beginning, Quarkus has been designed around a container first philosophy. It means that Quarkus is optimized for low memory usage. Whenever we go ahead and design a program using Quarkus, the amount of memory which the application consumes is low. So when we say low, I'm comparing it with other application frameworks like Spring Boot. So how many of you are familiar with Spring Boot? A thumbs up can be great. I don't see any thumbs up right now. Does that mean none of you are? Okay, I see 6. All right. So folks who are familiar with Spring Boot, whenever I say low memory usage, I'm comparing Quarkus with those frameworks. So Quarkus is optimized for low memory usage and fast startup times. So the moment I'll go ahead and start my application, starting the application will be quick. Now, Quarkus has a support for Graal VM and Substrate VM. The build, most of the processes which occur in Quarkus when we code an application happens during the build time. So as much processing as possible is done at the build time. So the application will only contain the classes that are actually needed at the runtime. Assume if I have a class which uses only date function or date libraries. Now, rest of the libraries, even though they are available as part of framework, they are not used while figuring out what is the current date, right? So those libraries are useless. What Quarkus does is while the build of the application is taking place, when we write and build the application, it ensures that any useless classes which are not required during runtime, they are removed when the actual runtime is happening. So at the build time, Quarkus figures out which all classes are required and which are not. What in turn it does, it ensures that low memory is used for our application and useless classes are removed during runtime. All these processes, they happen at build time, so Quarkus easily takes care of ensuring low memory usage and faster start. Now, Quarkus also reduces the reflection usage, and Quarkus provides native image pre-boot. It means when running a native image Quarkus pre-boot, as much of the framework as possible during native image build process. That results in a native image that has already run most of the startup code and serialized the result into an executable, resulting in faster start. So these are like few of the basics of a container first application, which Quarkus satisfies. Let me move to the next slide. So we discussed about container first. Container first means Quarkus is tailored for Graal VM and hotspot. Amazingly fast boot up times and low memory usage, offering near instant scale up and high density memory utilization in container orchestration platform like Kubernetes. We use technique we call compile time boot. So the technique used here is called compile time boot. During compilation or during building the application, all unnecessary classes are removed. Now, we already discussed about imperative and reactive style of programming. Both are supported by Quarkus. And Quarkus provides a cohesive, fun to use full stack framework by leveraging a growing list of 50 best of breed libraries. So most of the common used libraries in Java, they are supported by Quarkus. We already discussed what Kubernetes native language is and how. So Quarkus is called a developer joy. This is one of the best features of Quarkus. Why it is called a developer joy? So us being a developer, when we go ahead and write code, to ensure that the changes which we made in the application reflects, we either need to go ahead and build again, or we need to go ahead and restart the server. That was for, these approaches were for monolithic or microservices architecture as well to some extent. What Quarkus helps here is, for developers, the moment we go ahead and make the code changes, they reflect instantly. And we don't have to go ahead and build the application again and again. Most of the applications which are built in like WCS or Hybris or ATG, some e-commerce application, they do support these features, but with the help of few add-on plugins. So when we restart our server and when we make the changes in the debug mode, in WCS, we are able to see the changes in real time. But for that, separate plugins are used. Same is the case with Hybris, where JRibble and other plugins are used. But in Quarkus, we don't need a separate plugin. The framework itself is capable of ensuring that the changes are reflected on the code. The moment we write or we change the code in the application, they are visible on the front. So since ages, Java has been blamed for slow startup. And that is one of the reasons why most of the serverless application, they are not built using Java. Instead, the preferred language for building such application is Node.js or Python or Go. But we have seen a trend where companies having more than 1,000 employees, so the language which they prefer for instant reactive style of coding is Node.js or Python. Only 14% of those companies, they use Java. And the reason why Java is not used by most of the microservices application or serverless application is because of its startup time. Now, with Quarkus, so who is this Quarkus and what is all this fun about? First of all, so Quarkus makes the application 10 times smaller compared to other frameworks. Additionally, it is 100 times faster in booting up the application. And both these are like key metrics for a serverless or a microservices application. Quarkus have support for live reload, which we already discussed, imperative, reactive, serverless, and microservices features, fat jars and native executable jars. We will see what these fat jars and native executable jars are. And Quarkus is also optimized for JAX-RS and JPA libraries. So we discussed all these features of Quarkus, but how is this achieved? So this is achieved. Traditional Java application, they used to have tons of classes loaded during boot time. Even though they were not necessary, still those classes were loaded. In turn, what it does, it occupies a lot of memory. Additionally, the Java framework used to load reflections, which used to consume more memory and degrade the performance. And then XML parser, annotation model. So for all those annotations which we see in our code, like @inject or @get, @put. So those sort of annotations, all of them, they are, when Java goes ahead and tries to read them, it degrades the performance. How Quarkus helps these things to solve these problems is all the annotations are processed during build time, compile time, configuration parsing, remove the useless classes which are not needed at runtime, and avoid reflections during runtime as much as possible. So this is how Quarkus achieves the faster runtime and low memory. If I compare a Quarkus application with Spring Boot application for a normal REST API, so if an application is written using traditional Java, it might consume like up to 136 MB of space. If I use Java libraries and Quarkus, we significantly reduce the application size by half. So it's around 73 MB. I also talked about a term called GraalVM in beginning, which is a tool for writing Java application. So in the Graal virtual machine, if I go ahead and use Quarkus, since Quarkus provides native support for GraalVM, then the application size is significantly reduced to like 12 MB. And these numbers or these charts which I've shown you, these are for basic examples. I mean, let's say a REST API which has a couple of endpoints. So if the application increases or if the application grows, then these numbers will even be more significant. Now, having said that, I'll stop here or I'll pause here and wait for you guys to ask any questions if you have. Because after this, we'll be deep diving into a few of the simple applications, coding applications. Okay, I'll assume silence as no. I hope
So
everyone is
Nitin,
paying.
is it
Yeah.
only specific to Kubernetes or does it have any other?
It has support for others as well, but it is highly tailored for Kubernetes.
Okay.
There are plugins available, and we can deploy the native jars anywhere using Lambda, AWS Cloud, Azure. So we can deploy these applications anywhere. So it shouldn't be any challenge. Do we have any other questions? Okay, I'll assume silence as no. Hope whatever I'm explaining till now is clear. If you guys have any questions, stop me right there and then you can ask me any questions. All right, so let's start coding in Quarkus. So I'll quickly bring up my browser here. Most of you would have heard of the term called Spring Boot Initializer. Similar to Spring Boot Initializer, I mean those who are familiar with Spring. So similar to Spring Boot Initializer, Quarkus provides an application to initialize or bootstrap our development. It's hosted at code.quarkus.io. I hope my browser is visible, right?
Yes.
Okay. So I've opened the site code.quarkus.io. Similar to Spring Boot Initializer, we have this where I'll go ahead and click on Start Coding. I think I already had downloaded the sample application here, but I'll go ahead and delete it. And then I'll start from fresh. Okay, it says it is already open. So let me quickly close this first. Close project. Try again. All right. So what I'll do right now, I'll go to code.quarkus.io and we will try to build a simple REST application using Spring Web. Now we have the search filter here. I see for web application, we have REST Easy Reactive. I'll go ahead and select REST Easy Reactive. And since I want to build a Spring Web application, I'll also go ahead and search for Spring Web. So I'll go ahead and add this extension as well. Now let me clear the filter. So on this code Quarkus IO, we have the group name. We can keep it as it is, or if we want to change it depending on our project need, we can change it. I'll let it be as it is. We have options for choosing the build tool. We can choose either Maven, Gradle with Kotlin. So such build tool options are available. I'll use Maven for now as a build tool. I hope everyone understands what build tool is, right? It is used for building the application. And Quarkus provides support for a hell lot of extensions. If you see here, this list is pretty exhaustive. It has support for database as well. We will be discussing, we will be coding an application using REST and database tomorrow. So that's part of day 2. Today, we will only be coding a very simple application for easy understanding. So what I did, I chose REST Easy and Quarkus extension for Spring Web API. Once we have chosen what libraries we need, I go ahead and I download it as a zip. Now I'll save this at a location. You are feel free to choose any location, it doesn't matter. And then once we download it, let's extract here. Okay, so the code is extracted. This is what Quarkus provides, right? So it has an initializer which takes care of whatever we need. So I needed REST and I needed Spring Web. All those dependencies are provided in form.xml. And then this zip file is created. So now to open this project, I'll need an IDE. We are free to choose any of the IDEs like Eclipse, IntelliJ, and others. Quarkus support is provided for all these IDEs, the popular IDEs. So for today, I'll be using IntelliJ IDEA. So I'll go ahead. I have this code with Quarkus downloaded here. I go ahead and select this. And now my application have loaded here. I'll let it think for a while. Till then, we will go through the README. Now, we know that our application code base is ready here, the Bootstrap application. If I want to run this Bootstrap application, the command which I'll be using is mvnw compile Quarkus. Dev here indicates that I want to run it into the dev mode or the development so that I can make real-time changes and the code executes properly. Once we run the application will be available at this particular endpoint. We can use any of the port numbers. If we want to change the port number, Quarkus provides application.property file, which is currently empty, but we can set the port settings in application properties, and then the application will be hosted on that specific port. Now, these are the commands for running the application locally. Now, if we want to create a jar of our application or package and running the application, we will use a command called mvnw and then package. What this does, it creates a jar. That jar have the libraries copied in Quarkus app library folder, target Quarkus app library. And to run that jar, we have to use this command, java-jar, and then the location of that jar. But these are not Uber jars. So Uber jars are those where all the libraries are already available in the jar. Here, the libraries are copied into the target Quarkus app location. If we want to build a Uber jar, we will follow the syntax of mvnw package -d quarkus.package.type is equal to Uber jar. So we need to specify that I need a Uber jar package. Quarkus has support for creating a native executable file using -p native. And if we don't have GraalVM installed, we can run the native executable build in a container using this syntax. So where we specify -native, the Quarkus native container build, we will set the setting as true. Now there are a few other related links as well. I hope by now this thing is synced. So in the beginning, I showed you a command that to run the application, we need compile Quarkus -dev. Now, what are we compiling here? When we loaded this project, there are a few out-of-box classes which came in. One is the REST resource. The URL is hosted at /hello. And if I access this hello URL either via Postman or in the browser, right? So it will produce this output. The controller class is defined here. So we have a greeting controller. Controller are part of Spring application, where they are defined by @request mapping. In REST application, it is defined by @path. Both internally does the same thing. I mean, we access the URL, we get a response. Now I'll go ahead and I'll start this application. So to start the application, I'll go ahead and copy this command mvn compile Quarkus. I come to the terminal. I paste it here. And this is the first time I have imported this project. So right now, all these dependencies will be downloaded. These dependencies are defined in pom.xml. So in the beginning, if you remember, I had selected two libraries. One was Spring Web and the other one was Rest Easy. So what code Quarkus IO did, it added these dependencies in the POM file and bootstrapped our application, right? So now if I read the logs, I see that, okay, the Quarkus application has started and it is listening to this particular port 8080. So by default, Quarkus starts at 8080. I'll click on this link. And if I see this page, it says, congratulations, you have made a Quarkus application. So we are ready with our first Quarkus application. You see how easy it is to bootstrap our application here. Now, in the code, I showed you that we have a REST API hosted at the path hello and a Spring Web application hosted at /context. Now, all these URLs are already present here. The content of this page is coming from index.html. Control. Okay, the page is sourced at index.html. If we want to remove this content, we can go ahead and delete that index.html from our application. Now, we have two REST APIs. One is hello, the other one is greeting. Let's access the hello. So if you see here, I access localhost /hello, and I got a response. Where am I getting this response from? This is coming from our get hello from REST Easy reactive. Now, if I want to access the Spring Web application, so I'll need to go ahead and use greeting because the path defined there is greeting. So if I change hello to greeting, it says hello Spring. So one of them is served by REST Easy, the other one is served by Spring Web. Both are like two different styles of coding. One uses request mapping, REST controllers, the Spring style of coding. This is the REST style of coding where we have the @path, @get, @produces, etc. Now, what we talked about initially is Quarkus. Right now, we saw how easy it is to start an application. I just defined what libraries I need. I imported the project into an IDE. I'm using IntelliJ. And then I just went ahead and used the syntax mvn compile Quarkus. And the application compiled, it automatically went ahead, downloaded all the libraries, and the application is up. I was able to access the application at localhost 8080. And then I was also able to access the APIs, the hello API and the greeting API. Everything was damn super quick. Now, traditionally, if this would have been any other framework apart from Quarkus, if I made changes in the application, so hello from REST Easy reactive, right? Instead, I would change it to hello world from REST Easy React. And then if I would have tried to access my API, these changes would not have reflected on the code, right? But with the help of Quarkus, what we are able to achieve is using Java, we are able to see real-time changes. And this is something which is awesome. Me being a developer, I love this, that I don't have to go ahead and build the application again and again for minor changes or major changes, right? I just change the code here and it automatically refreshes on the front end. Now,
Hey, Nitin, I have one question.
Yeah.
This is similar to Spring Developer Tools, right?
Are you referring to Spring Boot?
Right, Spring Boot.
Right. So in Spring Boot, you have to go ahead and start your application, right? You have to build your application. Right. So what you would have noticed here, I did not do anything. I just changed this to Word and I clicked Control S.
Yeah. Same thing happens in Spring Boot
Agreed.
also.
Right. So that's why we have a session on the third day to differentiate when to use Quarkus, when to use Spring Boot. Right. And the major differentiation here is the performance and the application size. So what Spring Boot does, okay, in short, Quarkus is also sometimes referred as Spring Boot killer. The reason because the live reload which happens here, if you see, it only took like 1.639 seconds. In Spring Boot, it takes more time to build the application. Additionally, in Spring Boot, so I showed you one chart. Let me go back to that chart. So if you would have built this application using Spring Boot, right, it would have consumed like almost 136 MB for this simple application. However, since we are using OpenJDK libraries of Spring Web and then REST Easy libraries, this application size is somewhere close to 73. So that's the difference of using Quarkus and Spring Boot. Which one to choose, when to choose, those things we will discuss in detail on third.
So Nitin, one question here.
Yeah.
So the functionality that you just shown now, is it applicable for additional of dependency? Like if in POM, if we add one dependency, then also it will just reload it live?
Exactly. So if I go ahead and make any changes here in POM, right, and then I'll click on save, it automatically downloads those dependencies in real time. I don't have to make any changes. The only change which I have to do as a developer is to introduce those dependencies here and reload the Maven file from it. That's all.
Okay.
And also that it will recompile the whole application and on runtime, right?
Correct. So the moment I'll click on this reload, I mean, different IDE may have different options. I'm using IntelliJ, which has this Maven plugin here. And then I click on reload all Maven projects. What it will do, it will go ahead and refresh the POM. Whatever dependencies will be downloaded as part of the POM changes, they will automatically start reflecting. So that's the beauty of Quarkus, which differentiate it from Spring Boot. Now, any other questions? Okay. So let me go back to the slide. All right, so we went to code.quarkus.io. We also went through the README to understand how to build the application in Quarkus. We created a simple application in Quarkus, the Hello World application. But this is not just a Hello World program. Here, what we did, we created a REST API. We hosted the REST API on a path called / on local host 8080 / hello. We also hosted the Spring Web application on / greeting path. And everything happened in real time. I didn't have to build the application again. I didn't have to, and whatever changes I did in the code, it reflected on the file. Now let's go to the dev UI. So by default, Quarkus provides a dev UI. The dev UI URL should be available here. Now, dev UI has few of these awesome views. So it provides all the build steps. So in the current application, what all build steps are followed are listed here. At what time it happened, those are listed here. Right? So that's for build steps. Second, for configuration, any changes which we make in application.properties here. So if I go ahead and define any property, assume database source, right? If I go ahead and define any property here, those property will be available in the dev UI config section. These properties can be for database or for any other third-party credentials, etc.
Nitin, can you change the server port right now and show it, please?
Yeah, we can change the server port. Let me quickly get that thing. I'm just grabbing the syntax. So I'll put it here. Quarkus HTTP port 8082. Okay. I'll check if the application has built properly or not. And now I'll go to the dev UI. Port changes. I'm not sure if it will reflect on the code because port is something which is created during build time. But so for that, I'll just need one build. Sorry, 8082. Usually port we define in the starting of the application. I had already started the application at that port. So I'll have to build it again. And to build it again, what I'll do, I'll go ahead and compile this application. Hopefully it should work fine. Okay, so now if you see, it says the Quarkus application is listening to 8082. That's how simple it is. I mean, port configurations we do in the beginning of the project. So you can change it to 8082 before starting on 8080. Since I had already started the project at 8080, that's why I had to build this again. But hope this makes sense, right? Now I'll go ahead and I'll access this application on localhost 8082. The same page with which we started, it is accessible. If I click on hello, the hello world from REST easy is accessible at 8082. Let me know if that answers your question.
Yes, Nitin. Thanks.
Okay. So I'll bring it back to 8080 because rest of my demos are coded in 8080. Otherwise, every time I'll have to go ahead and change the URL to 8082. I'm compiling the application on 8080 again. And you would have noticed how quick these things are, right? So it has faster boot up time. Changes are reflected on the fly. The application is ready. So localhost 8080, I go ahead and hit it. And now 8082 would be down and 8080 is up. So I'll bring down 8082, code with Quarkus. Now, most of the time, since we are building these REST APIs, we want to see how these APIs look. And for that, we have a Swagger API, which is also available in Spring Boot, right? So since Spring Boot provides Swagger API, why not Quarkus? So to ensure that we have Swagger API, what we need is just one extension. To get that extension, what we'll do, I'll go ahead and import that extension. I can go ahead and change the POM file right away, or I can use this syntax of adding the extension. Right. So if I go ahead and add a dependency, let's check the POM file. In POM file, we only have two dependencies: Quarkus Spring Web, REST Easy. These are the dependencies which we selected in the beginning. Apart from that, I don't see any other unnecessary dependencies, right? So now let's go ahead and add the Quarkus small ray open API. What this will do is it will enable the Swagger UI in our application. So I go ahead, I go ahead and import this Swagger small ray open API plugin. That was quick. Now I'll go ahead and compile the application. So adding libraries to Quarkus project is super quick. You go ahead, give the name, the libraries will be imported. The other option is, now you see here, the dependency for Quarkus small ray open API is added here. It is automatically refreshing and syncing the libraries. It's ready and the application is accessible at 8080. Right? So I go ahead, access this application. Now Swagger API is hosted at Open API. So /q Swagger API. And our application had two REST APIs right now hosted. If we go ahead and create more APIs, they will be listed here. Currently, we only have two APIs, one for hello, one for greeting. Right. So to test our API, we go ahead, select, try it out. And what it does, the response code for that API will be 200 if everything will be successful. It accepts text plain. It gives a string output. So to check it, let's click on execute. We triggered this post request. The call was made to localhost 8080 hello. And then our response was created here. So we do have support for Swagger UI as well. Now, let me go back to my slide. So config property changes. Let me show you from where we can make config property changes. So when I say config property changes, I am referring to application.properties, any property which we defined in this file. Like we did, we changed the port number, or we can add database credentials. So a few of the sample database credentials which I can show you, or which we will be dealing with tomorrow, is these kind of syntaxes. So we go ahead and define a DB kind, username, password, the URL, etc. So all these configurations, we can either come to application.property, make the changes, or the other option is we go to the, in dev UI, we go to the config editor. So anything which will be present in application.properties will be listed at the first. Right now, we don't have any property, that's why it's not present. I can quickly run a sample program and I'll show you where I have few config properties available and we'll be able to see them here. And HTTPX, all the config properties of the framework, they are also available here apart from application properties, which we define as custom. So we can edit these configuration settings from the dev UI config editor. Additionally, we can see the list of endpoints. So we have greeting, we have hello. Open API UI, which is nothing but the Swagger API. That is all. That extension support can also be easily added, which I showed you. What else? Okay. So there are a few endpoint scores we can check. So right now, when we triggered call to our hello service or the greeting service, we got the response correctly. The application did not fail. That's why it is giving a score of 66 out of 100. I mean, that's the out of box score. If these APIs start failing, then the score might reduce to like 33 out of 100. That's it. Next, okay, there was one more thing which I wanted to discuss that was related to error. So traditionally, how Java stack trace is printed is if I go ahead and make some error in the code and then access the logs, the error details are provided at the end of the stack. But what Quarkus has done or what Quarkus has tweaked is it goes ahead and provide the exception details right at the top. So developers don't have to go ahead and fiddle around at the bottom. So let me intentionally make some mistake in this program. I see that, okay, I have removed the single quote, right? And I've made this change in Hello API. Let's access this side. The Hello API. I'll change the port to 8080. And that brings the stack trace. And in the beginning of the stack trace itself, it is telling us what the error is, right? So unclosed string literal. I don't have, assume a scenario where we have our program is small right now, but assume a scenario where one class is calling the other class, the other class is calling some other class, where the stack trace is pretty big, right? Developers have to go ahead, keep on scrolling down to figure out what the error is. In Quarkus, it has been tweaked and the error has been brought to top. So it is clearly telling that greeting resource as an unclosed string literal. We will go ahead, see the error. We can quickly go ahead and we can fix it. That also reduces the time. If I come and refresh, our application is ready. And that's how quick it is. So usually when front-end team are working on HTML, they are receiving this kind of feedback. So they make the code change in HTML, their feedback is automatically rendered on the front end. But similar capability we have achieved using Quarkus. And that's the beauty of Quarkus. I will stop here because we have already reached our timeline for today. And we have covered whatever we wanted to discuss as per our agenda for today. So I'll pause here for a while and wait for any of questions from you guys. And we will again begin our session tomorrow at the same time, where we will code an application which will involve database interaction, a REST application which will involve database interaction using Quarkus. I hope whatever we did today was clear. A thumbs up or reaction would be great. You can unmute yourself and give me feedback or suggestions. All right then. I see some thumbs up. What about the others? All right. Fine, then let's connect tomorrow if you guys don't have any other questions and continue the discussion on Quarkus tomorrow. Thank you guys for joining this session and have a great day ahead.
Thank you, Nitin.
Thank you.
Category